I think we're live. Oops, I forgot to put my speaker in. That's going to be loud. Sorry. We paused here. Ready? This was part of your homework, and if you didn't do it, we're going to do it together really, really quick, but I'm going to take some shortcuts. I'm not going to do every single step for all of these. So if we were combining phosphorus and strontium, which one goes first, metal or non-metal in an ionic? Metal. So the positive metal is strontium. Oh, pen just stopped working. Don't do that to me. You worked 5 seconds ago. Okay, let's try my old. Works now. So strontium, what's the symbol for strontium? I know it starts with an S, but is it SR? What's its ion charge? 2+. Then we have phosphorus. I know that's a P. Is its ion charge 3-, I think? So if you wanted to join those together and have a stable compound, how many of each would you need? And this is where you can use this shortcut called the crisscross rule. And until you get good, I encourage you, draw the arrows. The formula is going to be SR, how many strontiums will I need for this to be stable? 3. How many phosphoruses will I need for this to be stable? 2. I would call this strontium phosphide. I'm not going to write that out. We just practiced that quickly. How many atoms, grand total, are there in this compound, in this molecule? 5. 5. Okay. Let's try a bit of a nastier one. Let's do the oxygen and aluminum, or as we call it, aluminum oxide. The naming part I can kind of do in my head. I say the metal, and then I eyed the non-metal. I can do that part. Which one is the positive? Aluminum, I'm going from memory, is aluminum 3+. And I'm going from memory, is oxygen 2-. Some of the common ones when I teach this unit I have in my brain, but by mail I've forgotten them again. Don't bother memorizing them. I got a periodic table for that reason. It's going to be how many aluminums? 2. How many oxygens? 3. This is an ionic compound. How can I tell it's ionic? Because it's metal, non-metal. Covalent means non-metal, non-metal. We're not going to be talking about those that much this year, Mitra. A lot more in Science 10, but we kind of plant the seed in Science 9 so that hopefully in Science 10 I can water the plant and get a better flower. Aluminum oxide, how many atoms? Oh, also 5. Is that okay? So let's continue on in our notes. Now it gets tougher. Multivalent metals. I'm going to go back to the PowerPoint because that's kind of where I was filling this out with you guys. And I wrote here, name these compounds. What would you call, what's Cu? Copper. What's Cl? Ide rule. What would you call this? Copper chloride. Name the second compound. Copper. Chloride. We got a problem. We can't have two compounds that are different. Look at them. They have different numbers in them with the same name. So right now, we might be tempted to say copper chloride and copper chloride, but this is actually technically, you can put a little, that's technically wrong and technically wrong. Now, why? What's weird about copper on your periodic table, your pink periodic table that all of you have out? I'll give you a hint. Yeah, it's multivalent. The problem with copper, and this is where when you get to the middle, the electron shells kind of overlap and twist, or when you get further down, the problem it turns out copper can be stable with different numbers of valence electrons. Copper is happy well, what are the charges for copper? The first one is the most common ion charge. What's the most common ion charge for copper? It's happier getting rid of 2 electrons, but It can be stable. What's the next ion charge that appears? It can be stable, getting rid of one electron. Is there another ion charge that appears on it? Actually, in real life, there probably is, but it's probably fairly rare and they didn't bother putting it on there. So the ones that are on your periodic table, Leah, first of all, you need to know are the most common ion charges in order. But there may be more that didn't bother, or it may not even fit. There's some that have like 7 or 8 different, and they're stable that way. So, some metals, really metals and metalloids only, can form more than one type of ion. Let me find your notes so I can underline what blanks we're filling in. Let me pause for a second. Some metals and non-metals can form more than one type of ion. We use a Roman numeral. I guess I didn't write these in your notes. We use a Roman numeral to show what charge the metal ion has. So you ready? If I was actually naming this, in the middle here, I would have to put a Roman numeral showing you what charge it must have been for this to be stable. Can anybody, by uncrisscrossing, figure out what charge copper must have if we need 2 chlorides? It must have been a 2 positive, and we would call this copper 2 chloride. And when I say that in English, then a science nerd says, oh, copper, you use the ion charge of 2 on that copper. As opposed to, what about in this first one? Since chloride is a -1, what must the charge of copper also have been? A +1. There's copper 1 chloride. Someone at the door? Come in. Yep. So this is where it's going to get trickier. Sorry. This is done only when a metal can form more than one type of ion. That part, Damien, is easy to tell. Any of the ones near the middle that have more than one ion charge, those are the multivalents, and it's tougher. So, what did I want you to write here? It says each of the compounds contains a I'll show you. Each of the compounds contains a I think I'm on the wrong page with you guys. That's why I'm so confused. Ah, there I am. Ha-ha. I'm back. Naming compounds with multivalent metals, okay? We're going to use Roman numerals to show what ion charge. So, if I told you iron 2 bromine, you guys have this in your chart there, yes? Okay. What we're saying is this. The ions here must have been, can you find iron? What's its valence charge? And the answer is several, right? What's its ion charge? Several. What's the most common one? What's the first one? Sorry? 3, then? Then, what's the next most common one? 2, then? Is there a third one? No, some do. And you know what? There probably is, but just doesn't show up often enough that we mentioned it. And also, you want your periodic table out as well? And the notes from, right? Find where we are, kiddo. Then your locker. Like the wind, my angel, like the wind. So, here, Rihanna, they told me which charge is on iron. Which charge do they want me to use? 2+. 2+. So, ready? Where I write the ions, it's going to be iron, they want me to use the 2+. Bromine, I don't have any choice. What's bromine? It's Fe2+, right? Iron is Fe? Right? What's bromine? What's its charge? Br minus. So now we can crisscross. What would the formula for iron 2 bromine be? Got more late people. So, what would the formula be? Well, there's going to be an Fe, there's going to be a Br. What number is going to be beneath the iron? How many irons do I need to make this a stable compound if the iron ion has a charge of 2 plus? 1. When I am I going to write the 1? Okay, I'm going to erase that. But how many bromides do I need? The formula for iron 2 bromine is FeBr2, except there shouldn't be a huge space between it. So I'm going to fix that because that's irritating to me. Okay? And I would call this as a name iron 2 bromide. I'd still use the IDE rule, but because it's multivalent, I have to tell whoever's looking at this chemical, Leah, what the ion charge that I used to make this particular compound is. By the way, how many atoms in this compound? I think I can zoom in even more, can I? Yeah, I can. Barely. 1 iron, 2 bromides. How many? 3. Now, it turns out not only can iron have a charge of 2 plus, but according to my periodic table, iron can have a charge of 3 plus. So now they want me to combine iron 3 and bromine. Okay, so if I do the crisscross rule, I would say this time they want me to go iron with a 3 plus. Now the nice thing for the nonmetals, you'll notice none of the nonmetals are multivalent. So what was the charge on bromine? Still minus. To figure out how many of each that I need. And remember, this crisscross was really faster than drawing those hook diagrams, which is kind of how we derived this thing, right? It's a nice little shortcut. It's going to be how many irons? 1. Am I going to write a 1? No. How many bromides? 3 this time. That's also a stable compound that can be formed as long as you have iron 3 ions to start out with. What would I call this? I would call this iron 3 bromide. How many atoms does this molecule, does this compound have? 4. Let's keep going. Sorry? I know, but my page has to move, I think. So we already did iron 2 bromine and iron 3 bromine, right? Your next one is copper. Copper is multivalent. Which copper do they want me to use here? The one, okay, so it's going to be, what's the symbol for copper? I'll see you. Oh, sorry, sorry, you mean okay, Cu, and copper can be several, really, you like that joke? That was, okay, never mind, note to self, use that one again. Copper can be plus 2 plus, or what? Oh, they want me to use the 1 plus. Nitrogen, hey, that's not multivalent. What's the charge on nitrogen? 3 minus. So the formula is going to be Cu3N1. Oh, am I going to write the 1? No. I won't take marks off, but it's unnecessary and I'm lazy. What would I call this then? I would call this copper 1 nitride. How many atoms? 4. 4. Right? Yeah, 3 coppers, 1 nitrogen. Gold, turns out, is multivalent. By the way, a lot of the ones that are multivalent we use quite a bit in industry because the fact that they're multivalent means we can combine them with all sorts of stuff. So copper, iron, gold, hey, it's not a coincidence that we make stuff out of them too. What's the chemical symbol for gold? AU? Oh, I'm sorry. You mean, thought you were yelling at me. Hey, you! No? Okay, note to self, that one didn't go over as well. Gold, is it multivalent? Which ion charge do they want me to use? 3 plus, which is the most common one. Chlorine. Minus. Okay, now I'm going to see if I can, without drawing the arrows, can you see what the formula is going to be? Au. What? Cl3. Okay. Would I do it without drawing the arrows on a test or a quiz? Never. Maybe in my homework I might try doing some of this in my head. Here in our notes, let's draw the arrows just so that we know what the heck we did. What would I call this then? I would call this gold 3 chloride. Do I need to use Roman numerals if it's not multivalent, Linda? No. So for column 1, lithium, sodium, potassium, and for column 2, for any of the non-multivalent ones, no Roman numerals, and I will take a half mark off if you use so going to your question, Matteo, I will take a half mark off if you put a Roman numeral when you don't need to. If it's not multivalent, don't put a Roman numeral. That I'll be fussy on. Oh, how many atoms here? Looks like also 4. You guys want to try these next 4 quickly on your own? I'm going to freeze the screen. I'll pause everything. See if you can get this on your own. Pardon me? Oh, IV is 4. Did I put Roman numerals on the back of your pink sheet or not? I can't remember. VI is 6. So IV is 4. V is 5. By the way, thank God we don't use Roman numerals for math. And it kind of bugs me that they use Roman numerals for this, but I'm stuck with it. So I'm going to pause the video. So when you do your crisscross, make sure you go lowest terms. This one was sneaky. It's not 2 and 2, 1 and 1. This one was sneaky. It's not going to be 2 and 6. It's going to be 1 and 3. I will say, Kyle, if you did this, look up. If you went 2 and 6, and you caught it and you went, okay, cross that out and just made that a 3, I'll live with that on your test. It's sloppy, but I'll live with that. But because I can erase stuff easily on my tablet, I'll do that. Okay? Is that all right so far? What's really tough is going backwards. Going from here's the ingredients to formula to name, not too bad. Going from name to formula, way tougher. So, I wrote here, each of these compounds has a multivalent metal ion. So the name has a, you can fill this blank in, a Roman numeral. To go backwards, I start by looking at the non-metal ion because that one doesn't change. And remember I said all your charges have to balance. They have to add up. They have to balance. The charge on this will never change, and the charge on the metal must balance it. This is approaching almost as tough as it gets. In fact, this one, most of my Science 10s still got wrong this year. Okay? Ready? CrBr2, CrBr3. Chromium and a bromine. The problem is, first of all, chromium, multivalent or not? Yeah? Ding, ding, ding. You got to catch that part. You'll have to notice when you glance at your periodic table, uh-oh, Roman numerals. Which Roman numeral? Well, what I'm going to do is I'm going to uncrisscross. Say what? Show you what I mean. The total charge on the nonmetal ions. Bromine normally has a charge of what? Mitra, you're right. 1 minus. How many bromines are there in this molecule? 2. So what's the total minus charge that I have? See it? It's 2 1 minuses. Tough to, but 2 1 minuses. So for this to be balanced, what does chromium have to have as its charge? Right? So it must be chromium 2 bromide. That's the only way that that could be stable with those numbers. Compare that with the next formula, which looks identical except for the subscript. Mitra, I'll go back to you. What did you say the charge was on a single bromine? 1 minus, right? How many bromines do I have in this second formula? So what's my total number of negative charges, grand total? You know what? The total number of negative charges is 3 minus. You know what that means? Yep. Oh, if only it was that easy. Mateo, what's the charge on a single sulfur? Because the nonmetals don't change. I can use that to work my way backwards. How many sulfurs are there? Mateo, how many sulfurs are there? Psst. Mateo, how many sulfurs are there? 3. So what's the grand total negative charge, Mateo? No. Times, right? So what does the grand total positive charge have to be to balance this? Now here's the problem. How many nickels do I have grand total? So what's each one going to be worth if they have to have a total of +6? Amelia, you're right. Say it nice and loud. 3. Like I said, I wish it was always as easy as the first two, but it's not. I have to clue in. I have 2 nickels. They have to have a total charge of +6. I guess, you know what? This is going to be nickel 3 sulfide. Let's try a couple more. You guys don't need to turn the page, but I do. Iron. Is iron multivalent? Yeah. Now, by the way, look up. If I gave you this, is calcium multivalent? No. So don't be going calcium because it's got a charge of 2 sulfide. I will take marks off if you use Roman numerals when you don't need to. So we're throwing a lot of stuff, Kiana, to check before you write anything down. Double check. Multivalent, yes or no? So, like I said, this is about as tough as we're going to get this year. So iron, multivalent, ding, 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 Roman numerals. Okay. What's the charge on iodide? One minus. How many iodides do I have? What's the total negative charge I have, Rihanna? So I have to have that. How many irons did they give me? Oh, so you know what? That 1 iron has to have a charge of 2+. This must be iron 2 iodide. This is hard. I told you it was. By the way, if you find this tough, you're normal. Half my grade 10s didn't get this year still. That was after seeing it twice. FeCl3, okay. Iron, multivalent or not? Yeah? Okay. What's the total negative charge on this ion? What's the total negative charge in this compound? Each chlorine is a -1, and there's 3 of them. So what does the total positive charge have to be? Is there only 1 iron? Yeah? Okay. Then it's going to be iron 3 chloride. Try this one. Try the 2 leads. The one beneath it with Hg, since Hg has a 3, that one's going to be about as tough as it gets. We'll do that one together. But try these next 2 on your own. I won't freeze the screen. I'll do them up here. You can look up if you get stuck. F is, oh, that's going to be... I think I'm right. I hope. By the way, you notice I've been giving you a bunch of tables. You can expect some of these same tables on your test for this unit, right? In other words, if you're getting the hang of this, then in theory, I can't call this easy marks, but it's marks you can all get, questions you can get right. But I will never call this stuff easy. It took me a while to wrap my brain around it. Why did I say that this next one is a bit yuckier? Okay, I got more than 1 metal. I'm going to have to do some real thinking. By the way, what is Hg? That's mercury. Why is Hg mercury? It comes from a Latin word for quicksilver because mercury is a liquid metal and it's silver, so it was nicknamed quicksilver. Like you could pour it. Anyways, okay. Is mercury multivalent? So Roman numerals. Again, if it wasn't multivalent, you would just say mercury nitride, done. Is it multivalent? Ding, ding, ding. Okay, we got to do some thinking. Look at the nitrogen. What's the total number of negatives it gives me? There's 2 nitrogens. What's each one worth as an ion charge? 3. So grand total? Which means I better have this, except how many mercuries do I have there in the formula? Matteo, how many mercuries do I have in the formula? So if I want the total to be 6 and I got 3 of them, what's the charge on each one? 2. This is going to be mercury 2 nitride. Mr. Dueck, you capitalize these. Actually, you don't need to capitalize them. It's just a habit I have, in case you're wondering why I capitalize the names. The element symbols are always capitalized, first letter. HgI2, I'm going to argue this one is a little easier because how many metals are there? Try that one on your own. I'll do it. And try CuO on your own. I'll do that one too. And if you want to, try that bottom one on your own. I know there's more than 1 mercury. See if you can get it right. I guess for Roman numerals, I should do the little bar thingy. Okay. Don't go as fast as me, but I want to get ahead of you so if you get stuck, you can look up, right? Don't copy. You're trying this on your own. Okay, it's got to be that. that a hand up? Yeah. Good. I'm glad somebody asked. So you're wondering about this one here and this one here. Are you okay where this came from, that I said each nitrogen is a -3 and there's 2 of them, so it's a -6? Always look at the non-metal, because those are never multivalent. I can use that to deduce what the metal had to have been to balance out all the charges. Okay? So that's why I always start out looking at the non-metal, and that's a total of -6. Can you see that okay, kiddo? 3 times 2. Yep. So this has to add to 6 plus, otherwise it's not a neutral compound. The second one always has to match this one. But then you have to say, okay, if it has to be 6 plus, and I have 3 of them, what's each one got to be worth if I got a total of 6? There's the 2. Is that okay? Oh, and yeah, it helps if you know your smaller times tables. Like your 2 and your 3 and your 4, basically, right? Okay. I'm glad you asked that, because you weren't the only one wondering. Turn the page. It says, do number 8 on the worksheet. What is number 8 on the worksheet? I think we did number 8 together on the... Yeah, we've done number 8 together. Right? We just finished that. Nearly done. Yeah. Nearly done, the toughest topic of the year. Hey, not only can stuff from that periodic table combine, but remember I said on the back of your pink sheet, there's those weird polyatomic ions. Those are ions that behave like a single atom. They're groups of atoms. You know what? It's sort of like a group of friends that does everything together, and you can kind of treat them as one person because they're always together. Oh, and they have a charge, which means they're going to bond. So polyatomic ions act as a group, and they can bind to single atoms, or they can also bind to polyatomic ions, but we won't vary it. We will only occasionally be doing a polyatomic plus a polyatomic. Now, how can you tell it's a polyatomic? Look at the back of your periodic table. See that chart of them? Just kind of glance down at each one. How can you tell it's a polyatomic ion? Because they look like that. And it's hard for me to explain what I mean by when I say they look like that. But hopefully you're noticing they all kind of look the same formula-ish, sort of. There's kind of, you'll recognize them. But they look like that. And they all have names. Now the IDE rule is no longer used. Now when you use one of those, you actually just use the name that's written there. Some of them have more than one name. Use the shorter name, because I'm lazy. So, oh, and a little note. Atoms in a polyatomic ion are held together by covalent bonds. Inside that group, they share electrons. But once that group shares electrons, they then bond ionically with the other ones. So polyatomic ions form, what did I write here? Ionic bonds with other ions. If you're not sure whether it's a polyatomic ion or not, honestly, count the capital letters. If there's only 2 capital letters in your compound, that means it's only 2 elements. It's not a polyatomic ion. Regular naming. So, if there's only 2, the IDE rule. If you see more than 2 capital letters, that means there's more than one element, more than 2 elements. This is going to be some kind of, this year, it's going to be some kind of polyatomic ion. So, more than 2. And you have to take that into account when naming the compound. What? Don't worry, that last sentence won't make sense much until we actually do it. But you have to take it into account when naming the compound. You know what? If you want a shorter one, you can say this. Use name from the sheet. In other words, if you look at the polyatomic ions, none of them end in "ide." Some end in "ate," some end in "ite," some end... Use whatever the name there is from the sheet. Okay? I asked the cat sitting next to me if he had any sodium hypobromite. He said, nah, bro. Okay. How many capital letters do you see in that particular compound? 3. That's got a polyatomic. Bro, B-R-O, is called hypobromite. And you'll notice also, it's a non-metal. Oh, sorry, let me point here. You'll notice also, it's a non-metal and a non-metal. That's a covalent bond. This is a polyatomic ion bonding with a metal. I told a chemistry joke. There was no reaction. Okay, fine. Writing names. So, the names of polyatomic ions don't change. So you don't have to change their endings, which is nice. Recognizing that a polyatomic ion is present is the hard part. But I just kind of gave you a trick. How many capital letters? So I wrote, remember to count the capital letters. More than 2. Oh, don't need to underline that. More than 2 means a polyatomic ion is present. Here we go. I'm psyched. We're almost going to get all of our naming. We're going to get all of our naming done today. I'll give you some practice. Sorry, you're going to get some. By the way, what we're trying to head for, if I play my cards right, I'm going to be giving you homework over the next couple of weekends, probably. Do you guys want homework over Christmas? That's our goal. So I'm going to crack the whip up until then, okay? We work hard, go strong, so that we can play hard. Not for me. Ready? So, I'll scroll back if I need to, but name these compounds. First of all, how can you tell that all 4 of these have a polyatomic ion just by glancing at it? More than 2 caps. Okay? All right. Look at this first one. I think there's the metal, and then to the right is the polyatomic ion. Sodium, multivalent or not? So no Roman numerals. I would call this sodium. And then from the back of your pink sheet, what's SO4 called? I know it's something. Sulfate or sulfite? Because there's both. 8? Sulfate. That's the name of that. We would call that compound sodium sulfate. That's a different, that's not SO4. What's sulfide? What's sulfite? SO3. And then sulfide is just plain old sulfur from the periodic table with no O attached. Didn't say this was easy. That's its ion charge. Right? But does the ion charge appear in the formula? No. It tells you how to write the formula. And we'll be doing that next. By the way, how many atoms are in here grand total? Ready? Count with me. How many sodiums? 2. Remember that. How many S's? What number is sitting right down there? It's invisible. That makes 3. How many oxygens?
4.
So grand total, this has 7 atoms. It's a bigger molecule now. Okay, is this one here polyatomic? Yep. You can also tell because there's brackets around this funky thing here. Okay, okay. Calcium, multivalent or not? No? So this is going to be called calcium, no Roman numeral. What the heck is NO3? NO3? Nitrite or nitrate? With an I? It's called calcium nitrite. Nitrate. Is that what you're saying? That's why I said with an I, and you said yeah, with an A. Okay. Oh, by the way, how many atoms are in here? This one's tough. In math, when you see brackets, what does that mean? Multiply and do it first. So you ready? In here, how many atoms are there? Grand total in the brackets. How many N's? How many N's? 1. How many O's? 3. How many grand total in the brackets? 4. How many 4's are there? 2, making a total of 8. How many calciums? There's 9. That has 9 atoms. Okay. NH4Cl. How can I tell that's polyatomic? Because there's more than 2 capital letters. Now, NH4, that's a positive polyatomic ion. It acts like a metal. It's not a metal, but it behaves like one. What's NH4 called? Ammonium. Cl. What do I do for Cl? Chloride. Now we're combining everything. So if it's just a generic from the periodic table, non-metal, I'd rule. Oh, how many atoms in there? How many atoms in this one? How many N's? How many H's? How many Cl's? So 1 plus 4 plus 1, 6. Next one here. Polyatomic, I can tell because of brackets and more than 2 caps. Oh, Mg, multivalent. Okay, we are going to do multivalent with these two. Ugh. That's coming down the pipe. Anyways, what is Mg? It's either magnesium or is it magnesium? Because I get that one and manganese mixed up. Magnesium. What's OH? And Lindsay, that's a base. We're just going to do these ones out loud together. Not going to write them. Na, first of all, polyatomic or not? Sodium. You guys have this on your sheet? You guys, we're just going to do these really, really. Okay, we're going to do them together. Good. Sodium, polyatomic or not? So sodium, what's SO4? This is sodium sulfate. We already did that one? Did we do CaCr2O7? No. Let's do that one. Calcium, polyatomic or not? Now, right now, none of these are going to be. Oh, wait a minute. I got iron. Oh, I got poly. Ooh, okay. Calcium, polyatomic or not? This is calcium. What the heck is Cr2O7? Calcium dichromate. Bacon. No, not quite, but very close. What would this be?
Oh, I see that.
Barium. Polyatomic? No. Whew. Barium. What the heck is CN? I know it's a railway, but what the heck is CN? Jordan's going to put her phone away before I freak out. Cyanide, like the poison. Okay. Who knew? KClO3. K is potassium. I know that's not multivalent. Potassium, what? Chlorate or chlorite? Chlorate? Okay, and you have to emphasize it because there's also chlorite. Okay? K3PO4. Potassium. What's PO4? Phosphate. You guys seeing how we're finding those pairs? Whew. Copper. Multivalent. Ding, 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 ding. Okay. Find SO3. What's its charge? So how many negative charges do I have? I have a total of 2 minus. How many positive charges must I have then? A total of 2 plus. How many coppers did they give me in this formula? 1. So what's each copper have to be? This is going to be, it's got to be a 2. What the heck is SO3? Sulfite. Iron. Ding, 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 ding. Multivalent, Jordan. MnO4. What's its ion charge? First of all, what is MnO4? Permanganate. What's its ion charge for just one of them? What's its ion charge? 1 minus. How many of them are there in this formula? So you ready? What's the ion charge for for a single MnO4? What's its ion charge? 1 minus. How many of them are there in this formula? Look outside the brackets. Jordan. There is 2. No, don't count atoms. How many of these ions are there? 2 of them. Don't worry about the atoms. No. Just stay with me, okay? Hang on, please. I don't want wrong answers right now. Just hang on. Each one of these is a 1 minus charge. And there is 2 of them. What's the total charge? Total charge, there's a total of 2 negatives. So what does iron have to be to balance it? This is going to be, can I write here? I'll just write it. This is going to be permanganate. So, ready? Now we're back to writing. It says, treat the polyatomic ion as one group. That means if you need more than one, you need to put brackets around the entire polyatomic ion. Say, what? I'll show you. Ready? Oh, sorry, I scrolled up. You guys can't see that. You ready? Here we go. Sodium hydroxide. What's the formula? We're going to crisscross. So the first thing we're going to do is we're going to find sodium on our periodic table. We're going to write it down. And we're going to write its ion charge. What was sodium's ion charge? Plus? Now, hydroxide. Is that an element? No, that's a polyatomic ion. Find it on your sheet. So it's OH minus. Oh. I did. It's OH. I just copied it right from my chart, right? Oh is right. Mateo, I'm not sure what you're asking me. It's OH minus, right? Now we crisscross. What's the formula going to be? That there is the formula for sodium hydroxide. Magnesium what? 8. A lot of kids, when they read this fast, they go magnesium and they see phosphide and they stay on the front of their periodic table. So Nicole, we really have to look out for these suffixes, and this is going to be a polyatomic ion. First of all, magnesium is Mg. What's its charge? 2+. Phosphate, what's its formula? PO4. What's its charge? Crisscross. It's going to look like this. How many magnesiums am I going to need? 3 is correct. And then look up for a second. I write the PO4. How many of those am I going to need grand total? Put it in brackets. 2 of them. Because you're treating it like one funky atom. Now, this goes to Rihanna's comment earlier. If I asked you how many of each atom grand total there was, yeah, then you times and stuff. But to write the formula and to figure out the charges, you got to be careful not to get them mixed up, right? Lithium chromate. Lithium. Chromate. Did they say chromate? Oh no, chromate. Where's that's on? Oh, there it is. CrO4 2 negative. Is that right? What's the formula going to look like? It's going to be how many lithiums?
4. 1, 2.
How many lithiums?
2.
2 of them, right? Crisscross. And how many CrO4s? I'm treating that like one funky atom. How many of those? Just 1. You can look up. This is technically not wrong, but it's really, really sloppy, so I won't do that. I just understand that there's just 1 of them, Kiana. Now, going to Rihanna's comment earlier, how many atoms are there? 2, 3, 7. How many atoms are here? In here, there's 5 times 2 is 10, plus 3. This has 13 atoms, but I don't use that part to do the formula or to do the crisscross or to do the charges. What can you do right now? So last day, I also handed out, can you find this section 3.2 homework thingy that I handed out? And I'll tell you the questions that you should be able to do now. And then I'll also, if you want to get a head start, tell you the questions that you might be able to figure out, but that'll be finishing on Monday. Also on Monday, probably I'm going to, or sorry, Tuesday. Also on Tuesday, probably I'm going to give you a big take-home quiz on this stuff. What's the take-home quiz going to look like? I'll probably take some of these same tables, shorten them down. Don't give me the stink eye. The take-home quizzes are good practice. Oh, got a stink eye there. Yeah. Okay, for now, you just have to temporarily write down what questions I'm assigning, and I'll let you get it in a second. So, you should be able to do from the front page, from the first. Anybody not have it? Just Mateo? Okay, just jot down which question. So from page 1, absolutely you can do number 1 now. Okay, it says identify each ion on each. So it wants you to first of all do sodium chloride, then it wants you to write the formula for sodium fluoride and the name, and it wants you to write the formula for sodium oxide and the name. Combine this with that, then combine this with that, then combine this with that, formula and name. Then combine magnesium with chlorine, magnesium with fluorine, magnesium with oxygen. Again, crisscross and proper name. Okay? Just because that's a weird one to kind of figure out. Absolutely number 2. Absolutely number 3. So definitely on your test, I'm going to give you the formula, say tell me the name. I'm going to give you the name, say tell me the formula. An awful lot. That's probably going to be about half of your test. Test is going to be just before Christmas, I think. Now, turn the page. Now we're multivalent. Ding, 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 ding. Tougher. Much tougher. But you should be able to do number 1. Now here, they're telling you which charge to use on these multivalent ions. So instead of making you figure it out, they're saying, you know what? On lead, use the 3+, although lead can be several different ones. Formula and name. Check your answers. From formula to name using Roman numerals. That's probably the single toughest thing I find. Because you have to look at this is Rihanna where we looked at the non-metal, figured out the total negative charge and said that's what the total positive charge has to be. Oh, is there more than one positive? I might have to do even more thinking. Number 3 is good. So you can do all this page. Polyatomic ions. I've just started talking about, I think you can do number 1. I think you can probably do number 2. Well, sure. There's some multivalent. There's a couple of multivalents. Number 3, I'm going to assign this on Tuesdays. I'll put a star here. You might be able to figure it out. Okay? But there's about 15 minutes left. You should be able to get most of that part done if you hustle. Thank you for your patience.